Hello, everyone. Let's take a look at problem 2.24, which asks us to solve a circuit using the node voltage method. So this is a little bit different than the previous problems. So the problem says that we have a circuit, and it's given in this figure right here. We know three different currents, and you can see that those currents are already labeled on this, right? So this current we know. We also know this one, and we know this one. So we have three currents, and what we're asked to do is determine or find the node voltages V1, V2, and V3. These node voltages have already been defined on the circuit right here. So this is node voltage 1, node voltage 2, and node voltage 3. So let's solve this using the cookbook, which you can find on Moodle. So first, we want to identify the extraordinary nodes. So what I did is I took a highlighter and I went through each one of these and I colored each node. Now I can see that the green, purple, blue, and orange nodes could be considered extraordinary since there are three different branches going in or out of that node. So this is step one, identifying each one of the nodes. Step two asks us to find a reference node. However, in this problem, there's already a reference node defined, and this is shown on the circuit by this symbol, which is the ground. So we already know that this is the reference node, which we'll say is 0 volts. So we will assign variable names in step 4, which has actually also already been done in this problem. So the variable names in this circuit are V1, V2, V3, and the ground or reference node. And as we mentioned, those were already defined on the problem. Now, step 5, let's write some equations for each one of these nodes. So for the green node, we can see that we're already at 40 volts here. So we're going to step down in voltage across this resistor to find the voltage at V1. So this is equation 1. Now for equation 2, let's take a look and see what the easiest way to find this will be. And we can see that the orange node is the reference node at 0 volts. So we know that the voltage 3 is going to be 0 volts plus the current going through I3 multiplied by this 18 ohm resistor will give us voltage 3. Okay, now what about this purple node? This one's a little bit more tricky, right? We don't have a current defined through this resistor or this resistor, and we know that we have three unknowns, right? Node 1, node 2, and node 3. So we're going to need a third equation and a third unknown. So let's think about this a little bit more. Yes, we could try making a KCL equation at the green node. So let's define a new current. Let's call it I4. And let's define current I4 going through this 6 ohm resistor right here. So with that current defined, we can say that I1 is going into that node, and I2 and I4 are coming out of the node. So we can come up with the expression I4 equals I1 minus I2 as an expression for the current there. I think this is going to help us come up with a third equation to solve for our third unknown, which is V2. So now we can write an equation, voltage 1 minus the current through this resistor multiplied by our newly defined current I4 is going to equal voltage 2. This gives us the equation V1 equals V1 minus I1 minus I2 quantity multiplied by the 6 ohm resistor gives us V2. Let's solve for all of these now to find our three nodes. So we have these three equations, and remember, in the problem statement, we were given I1, I2, and I3. So we'll plug in or substitute the proper values and come up with 36 volts for node 1, 18 volts for node V3, and 18 volts for node V2. I hope this helps you understand how to use the node voltage method a little bit better, and I'll see you in the next video.